much, Professor Patnaik, for introducing myself to this platform and also giving me a chance to speak to this august audience. In fact, we are meeting in virtual platform courtesy COVID-19. And another is that this is the post-launch session. So I think all of you have enough energy and to spend through the 1.5 hours with me. And in fact, this will not be a session. I shall take you through a journey to different terrains. So it will be nice to interact with you and throw some light to different aspects of today's topic, that is machine learning for smart city applications. So let me share this slide so that I can carry on.
Yeah. Yes, now it is visible.
Okay.
Yeah.
So the title is Machine Learning for Smart City Applications. As Madam rightly pointed out, it is related with Imprint project, Intelligent Surveillance Data Retriever for Smart City Applications. This is Ministry of Human Resource Development and Ministry of Housing and Urban Affairs. This is a multi-domain task like accident detection, crime detection, traffic control, smart parking, pollution. So many domains are there. But I shall concentrate on one domain, that is crime detection. And crime detection, two different aspects, that is intrusion and loitering, because there are different domains in crime detection also. So in the process, I shall a little bit glance over smart city, then little bit of artificial intelligence, IoT, in fact, what is required for this task, for this presentation. And lastly, I shall give these two case studies, as I told, that intrusion and loitering. So they are little bit nearby, but there is a basic difference between intrusion and loitering. And these are all related with crime activities. And at the end, I shall also show you two videos, what exactly we have done. So let me first discuss little bit on smart city, because that's a catchword right now. Everywhere we're having the adjective of smart sensors, smart city. So this is a Government of India initiative under this smart cities mission, because many of these cities are converted into smart cities. And in fact, in our Odisha, even Bhubaneswar and here in Rourkela, that is also are supposed to be converted. This is the process of conversion. So that National Smart Cities Mission, what is its aim? That is for already urban location is there for renewal and retrofitting. That means upgradation, which was not there earlier. And it will be friendly to the citizens. And particularly, it will cater to the key areas, like as I told earlier, public security, economy, mobility, environment, living, and governance. So those are the aspects we generally looked into, and these are the parameters of criteria which generally makes a benchmark for a smart city. Then what is the definition? In fact, it is not new. The term is not new. Everyone knows about, has listened about the smart city. But exactly, there is no clear-cut definition. But This has got some parameters and criteria. So there is generally 4 pillars of comprehensive development. That is institutional, physical, social, and economic. Those are generally four pillars which is targeted, taken care of for smart city development. And when you are developing a city or converting a city into smart city, it should be in our context. That means Indian context, because every country has got different geological configurations. Many things are different. And it should be not a one size fit. That means even every city, then there should be some difference. All cities are not same. So this should be not a generalized solution. It should be city dependent. So in these cases, what is exactly the domains? Already I have told few domains, but these are the domains which comes into picture. That is smart healthcare, smart security. I will be concentrating on this domain, smart security. Then smart building, smart governance, smart education everywhere, then smart infrastructure, transportation, water and sanitation, town and planning, and smart energy. These are exclusive set on which the different components come into picture. As I told, I shall concentrate on smart security. So I shall concentrate these two things, examples where it can be implemented, can be intelligent video surveillance system, which I have made it bold so that I'll focus on this domain. That is also one sensor-based security system. Same thing which can be in video form, can be in sensor-based also. How it can be achieved? There should be hardware products as well as software applications. So to retrieve and analyze. So there will be a lot of heterogeneous data. Sensor data, image and video as well as audio. A lot of data will be gathered because video itself, it takes a lot of data and there will be a lot of data involved. So it should be integrated with IoT. And that way, it will be intelligent surveillance system. It is equivalent to, it will work as smart dogs. That means instead of human beings, they will serve as the purpose 24/7. Just okay. So then implementation aspects. How can we implement? It should be efficient. And the impacts will be, generally I am concentrating on security now, not on all the aspects of smart city. So if at all we achieve that smart security, it should be automatic, smooth, and fast traffic management. Then comprehensive network of crimes, accident, unfortunate death, loss of life, and taken care of emergency services as well. In summary, it should give us a comfortable stay. Few applications of smart security. Traffic light signaling. Then suspicious, abnormal, crime activity detection. So all the words synonymous with each other: suspicious, abnormal, and crime. I shall come back again to this point because first of all we discussed about the complete domains of smart city. Then we concentrate on smart security. Then we shall concentrate on second point, that is suspicious or normal crime activity. Then there is also smart parking system, transportation, and emergency service management. These are all coming under smart security. So these are few things about the smart city, how in fact the objective came into picture, how we thought of writing this project. Then bit of idea about the Internet of Things. It is also known fact. So it's a combination, engineering as well as computing, and it has got a lot of devices, or it is an embedded computer, sensor, actuators. They're connected through online. What we achieve by this? Communication between person to object and object to object. That means machine to machine. That communication can be established. And engineers face this task to make the complete world a nice place to live. Then on which principle it works? Smart devices collect data first, then relay information to one another, process the information collaboratively between themselves, they do that, and then communicate to either human beings or machines. And the capabilities of these various capabilities are there, like sensing, robotics, computational analysis. So many capabilities are there for IoT. Then what is the definition, standardized definition of IoT? This is given by IEEE. Whatever I discussed till now, that is the summary of these things. And the definition speaks that. Interconnect all the things with the help of sensors and smart objects, which will make them catchwords are intelligent, programmable, and ability to interact with humans. So we have discussed a little bit of smart city, then IoT, then which will be utilized in this? Machine learning or smart city application. So now we are coming over to the artificial intelligence. I'll just glance through all these things because I understand that these things must have covered in earlier sessions. So AI is related with machines just to replicate human beings. And a subset of that is machine learning. So it has got plus points: high-end computational infrastructure, efficient algorithm, and minus points: lack of proper interpretation. Then, as I told, machine learning is a subset of AI. So it enables machines to improve its performance with the help of patterns and correlation. It is suitable for small and medium-sized. Computational complexity is less. Some algorithm can be interpreted, some cannot. Feature extraction is engineered and it has got less accuracy. Then a subset of that, representation learning, because I am moving towards what exactly we have used. So it's a representation, extraction of the information with the help of classifiers and predictors. Now the domain increases, suitable for small, medium, and comparatively large size data set, because the data set will be a crucial factor for us. It reduces dimensional reprogramming, moderate computational complexity, and here disadvantage still feature extraction is not automatic, but accuracy is a bit more. Then finally we come out of the deep learning. This is what we have employed in our work. So these are already all representation learning methods. Simple but nonlinear modules. And it transforms from one level to the higher level. So it is the layers which are there. It is self-learned. So I have hierarchical learning. Advantages of deep learning. Accuracy is better, suitable for large data sets. As we tell, it is video-based intrusion detection or loitering detection. A lot of data has to be handled, and here deep learning fits well. It can handle multiple data sets. It can also adapt to different domains, and it gives an automated pipeline, complete automation from feature extraction, classification, all that. But it takes more time. As such, it supposed to handle large data sets. When data set is high, it should have high-end computational infrastructure. Here also little bit of lack of interpretation is there, but those broad points will help us. Then there is bit comparison between machine learning and deep learning. Here, machine learning is a step-by-step approach, but deep learning is a one-window system. Most of the things are test-rich. Bit comparison between the graph between data and performance. Mark this graph. When data is less, volume of data supposed to be handled is less, traditional machine learning works well, or shallow neural networks also works well. But when data is high, naturally we should go for deep neural networks. What is deep? Actually, when we tell deep, what is deep? So there is no universal one, but more than 3 we can take as deep. Though there is no perfect number, but accuracy increases with the number of layers, but to a certain extent. But when you increase the number of layers, there is more complexity. And naturally, we have to, this is become difficult to handle. So there should be an optimization. What should be the number of layers and what we expect and what the resources we have. So these things need to be optimized. Then coming over to what I was telling, the case studies, the work which you have done. First of all, intrusion detection. What exactly intrusion is defined? Everyone knows this. Well, it is unauthorized entry. To which places? Prohibited zones, but there is no one else, or high risk security zones. But when intrusion detection is there, one has to observe it. That is what the term is seeing is believing. That means we'll detect as well as we shall visually observe. In the process, I have given a lot of references. Those who are interested to work in this area later on or who are working, they may find the references useful. What are the conventional, what are the processes being used, or what are the different types? Few of the types we have mentioned here, video based, in fact we are using this. There can be other alternatives, micro Doppler, infrared, vibration detector. There are few examples or few methods by which intrusion can be detected. But why we should take video based? What is its plus points? So it enables for real time, and the person concerned can take preventive measures. But the conventional methods, as I told, they are not that much efficient to handle online performances. That means it should be high speed and computational complexity should be less. And what it goes in favor, that we have efficient general purpose processors and video cameras also. Cost is not too high. So these are the factors which gives a superiority. And in fact, those are the factors which we have chosen why we should go for video-based surveillance system. And again, one more positive factor in this direction is that it can be used for multi-purpose applications. The same platform can be little bit modulated to suit different applications. Then this is the system model, practical implementation of intrusion detection. I shall explain the different configurations, different components after this, but have a look at it. It has got network camera, ROI, region of interest. Then the number of cameras can be more. And we have got edge computing device. Then cloud computing, then end users. That is what the configuration. The configuration for loitering detection will be also similar. Little bit difference in components. I shall explain when I shall go over to the loitering. Let me explain the components involved, steps involved. As I told you, it consists three: is cloud computing and user interface. First of all, it has to be computed at edge, then handed over to cloud, and then user need to be intimated. What we have used here, camera is this Hikvision 4MP, and edge computing device. I shall give it specification later. What exactly the specifications we have used. So NVIDIA Jetson TX2 development board. Why you have taken this NVIDIA development kit? Processing speed is high. We observed that this processing speed high because we are dealing with real-time application. So that will be the best for us. We choose out of the different options. So once intrusion has been detected, I shall also later on explain how the intrusion is detected. It will be sent to the cloud through Wi-Fi. Then naturally cloud will compute and it will publish to the subscribers. And we have used Twilio, which is a communication platform for our purposes. And we have used this for both intrusion as well as loitering. Communicate between the cloud and the end users. Then what is supposed to be done by the user? The user draws a selected area. We have to define which area is supposed to be our intrusion free and or region of interest. We cannot scan everywhere. We have to define this zone is restricted zone. So the user user is free to choose shape as well as size. And in fact, it will be in GUI. You can obtain from that. And region of interest can be, as I told, it will be of any shape and size. It can be a polynomial of in how much we want, it can be given. So the user has to receive, because you are discussing about the user interfacing. The user has to receive visual, location, and time as well as duration. At what time he entered into the region of interest and how much time he stays there. So we can get both through WhatsApp, through email. So after the 3 steps, edge computing, cloud computing, and user interface, then this is what we should do. What is the step-by-step approach? It has been described in sequence diagram. So in sequence diagram has been simplified in the flow chart. But sequence diagram gives a elaborated steps, step by step, minute details of how intrusion is detected. So same thing, both are same. So we get the video stream, then we have got sampling frames we develop. We detect the object, and then if it is objected, then we have the feature extraction. I shall explain these steps later on also. If it is detected, if the intrusion is detected, then only it is tracked. Then we intimate to the user. So the sequence diagram, as I told, explains relationship between various entities. The intermediate steps, which is there in the sequence diagram, are time dependent. The processing time of other executions is constant, but algorithm processing time is different. That is what algorithm we are writing, that is different. And our job is to reduce that execution time of the algorithm which we are developing. That should be for real time as well as online. So then what are the methodologies? How we achieve our goal? So we have kept a target. It should have high processing speed. It should be low latency. Delay should be less, and accuracy should be high. Keeping these 3 factors into mind, we have optimized our resources, what we should use. So steps are, first of all, object need to be detected. Feature need to be extracted. What feature we shall extract for our object detection? I shall convey during the course of the journey. Then intrusion has been detected. Then the person concerned has been tracked. So this will be the 4 steps which will get us the intrusion detection. We have used, while discussing about this deep learning initially, I was discussing why we should use this. That gives high accuracy and robustness, where complex surveillance environment. For that reason, we have used
Are others getting the audio?
No, madam.
No, ma'am.
Are disconnected. Huh? Wait. I'll just call in. All please wait. He's again connecting.
okay.
Yeah. Yeah, again.
Sorry for the disruption, because we do not have control over many factors, and this is one.
It's okay.
So let me share it again. Is it okay?
Yes.
Is it okay?
Yes, carry on.
Yes, sir. Yes, sir.
So you are using let me continue where I had left. So we are using yellow algorithm for object detection. You only look once. So that is the reason why it has been used. His detection is high and high accuracy. Yellow has different versions. We have used version 2 because, as I told, accuracy in general, accuracy is high, but it gives less alarm. That means object is not detected, but it tells that yes, object is detected. So that is for real-time applications. This version is more beneficial. I have told at the beginning the factors which we have kept in mind while deciding the various components. So this version LOV2 is version 2 is one example of that. Then next step was feature extraction. So which feature we should take into account? So feature extraction in this sense, this case is, so here we have taken center of the mass into consideration. This is the object representation, symbolic representation of the object, and the user is supposed to make the bounding box. And we have to find out the center of mass. How will we get it? And in fact, there is one more discussion also, shifted center of the mass. The sketch shows PC and PSC, shifted center of the mass. Why at all we have done that? Center of mass would have been enough, but why should you go for shifted? So as I told, it will have a rectangular bounding box. Let us say the sketch I had shown with W, height H. Starting point already I have shown P0. So the entire box cannot be used for tracking. So for the to computational efficiency, we have taken center of mass, and it is calculated x0, x is x0 plus w by 2, width by 2, middle portion, and yc h by 2, y0 plus h by 2. So this is the middle point. This is center of mass. But I had told earlier that we have shifted it. Why you have shifted then? Center of mass would have been enough. The video cameras we have generally placed at a height which is unreachable to the human beings. And naturally it has to be inclined theta to observe the ground. So it will give us better coverage, and we will find a suitable restricted zone. So the center of mass which you obtained, that is PC. Now I can point that PC as shown in this case there, center of the mass, center point, is at different level. Human beings are working. But ROI, region of interest, is in ground. Two different levels are there. We have done experiment in both. With the center of mass, here in fact we have made the contribution here, center of the mass and shifted center of the mass, and we got better result, better accuracy with shifted center of mass. How we got it? So XCSC, it is equivalent. That is not change. Only YSC changes. It is, we have taken it to make it down YC by F. How we find out the F? So the mathematical expression we have solved, and we have experimentally found that when angles 0, F is 2, 30, 1.1, and 45, 1.5. Generally, we have kept it at 45 degrees centigrade. Sorry, 45 degrees. I have told that the accuracy we have shown experimentally that the accuracy of detection increased when we go for a shifted one. Lower is the center of mass, lower is the accuracy. Lower is the center of mass to selected ROI, region of interest. Then how will detect the intrusion? The person will enter. Earlier I have told that the ROI already you can choose that it should be polygonal, what the user will want, he will make the site. It is his decision. It is entirely depends upon us, which area, what size, which dimension the restricted zone should have been, ROI. So whenever the person enters into the zone, we can tell, in other words, the shifted center of mass enters. I shall show a video in this regard at the end. It will be treated as an intrusion as soon as it enters into the region of interest. What need to be done after that? The total number of frames has to be counted. Why? What is the total duration the object stayed in the region of interest? What is its objective? Why at all he should be staying for such a long time within the ROI? It is restricted, but still he stayed. So that we shall get at what time it enters and how much time it stays. Both the informations we got by our proposed IDS. We have observed that this person has intrusion. Then he has to be tracked. And we have used simple online real-time tracking. Why you have used it? Because initially also I had told all the things, LOB2, SORT, all the things we are keeping our objective in mind, which is best suited, and our available resources as well. It will help us for multiple object tracking. Here, in contrast to other methods, it takes only the previous and current frame. That means frame 4, frame 3, not frame 2. And that way complexity decreases, but it works well. So this object moves from frame to frame, and that way we can able to know the lifespan of the person staying inside the ROI. Then what are the specifications of the components which we have used in our experiment? Edge device and workstation. This is just for the completion, for the formality, just we have shown these things. We have used this one for our experiment. This is the experimental setup. What is environment in which we have developed. Then we have employment of the software. It can be offline. That means the data will be taken, but analyzed later on. Offline analysis. It can be online. We are observing when everything is going on. We have not recorded anything. We are just observing anything. So these two GUIs we have developed for our proposed ideas, and we have done experiment on that also. That is for software implementation. Then have a look at this figure A. This ROI is drawn by the user. I told you earlier also, this is complete freedom. This is the freedom of the person who have to choose it. These are different steps. Whenever a person enters into that ROI, figure B, then the region of interest becomes red. A alarm is given and the bounding box is in yellow. Then the figure C, it is a different ROI. It's a road, so it is a different ROI. Not road, in that parking area. So in that cases, when multiple persons enter in figure D, it is detected as intruder. Same ROI, if you can mark it, ROI becomes red and bounding boxes has been developed. The earlier upper row was for single person, but the lower, it is for multiple persons. That means our algorithm is efficient to handle all sorts of persons. Classification we have made, we have to, initially we have to give to algorithm what we are supposed to track, whether it is aeroplane, whether it is bird, whether it is human beings, whether it is car, whether it is bus. So classification we have to give. I shall give a table what should be the different classifications. Generally, I employed different classifications. Then one more example we have taken. All the things which you are showing, these are all developed in our lab, and the location are all near the electronics and communication building of NIT Rourkela. So this is figure A shows that we have taken the ROIs like this. Figure B, there is multiple persons. Almost same what we have discussed last slide. Different location, different polygon, different ROI. So that is the reason why we have shown this. Then one more difference. Figure C shows the ROI. Mark the ROI in the figure C. Then figure D, now the classification is for car. So a car has been detected and the bounding box has changed to red. The region of interest has changed and bounding box also. Then we have drawn a performance parameter, intrusion profile, time versus intrusion, how much time it stays, and gives us the real-time status. So the shaded one, it shows at what time it was there inside the intrusion. Then real-time notification. I told at the beginning that WhatsApp message as well as mail will be given to the person concerned, user. So this is notification in WhatsApp, right hand side, and this is the mail he has received in his mail ID. Then we have compared with the different algorithms, how much they have got, how much we have got. So here, have a look at the upper row, the accuracy also at the extreme right hand side. We have classified the how the method of object detection, object tracking, intrusion, and FPS, frames per second. Above 3 are for offline analysis. Still, our accuracy is higher. Different data sets we have taken, live video, everything we have done, parking. Here all the data set, different data sets we have used, and different frame per second we have taken also. We have used shifted center of mass. As far as the FPS is concerned, we have found that this will be best for in this zone. And we have almost got the accuracy in the range of 90s. So this can be applied. So that should be a complete intrusion free. That means all defined and trained classes. That means definition has to be there and training has to be there. There may be other zone where persons are classified as intrusion. Other objects are not. So that class has to be defined as without the person. Then vehicle, bicycle, bus, car, or no fly zone. As I told initially, bird or airplane. So the algorithm should know what that should detect as intrusion. Other classes, it will leave. So let me summarize what I have told as far as the method is concerned. Let me refresh the memory as well. So development of a novel intrusion detection. The class of intruders has to be defined and trained also. One more flexibility contribution one can take. Region of interest, any shape and size. Computational algorithm, complexity is less. And we have given real-time notification also. Everything at a stage, job is completed. So the person is aware of this and he will take charge of the damage if anything. Then the next application, loitering. I have given the definition of intrusion. Everyone knows that, but still I have defined in this term. So we are defining, they are close, loitering and intrusion, somewhat close. So algorithms will also be similar a little bit. So loitering, to define in terms, who spends abnormally long time duration. Time duration spent in the same area is more, and movement is slow. Final displacement is less. He is moving around, but final displacement is very less. So that we can conclude that this is loitering. What was your motivation to do that? First of all, initially we saw that the data gathered is too much, and a human operator cannot do that. Even if you'll do that, it will be with error, efficiency be, it will not be too much. So we thought of to develop a fully automatic one, and it will prevent the crime also. Even if there are a lot of works, but still we have improved upon. Exactly what is out of this, what are the problem statement, what we take out of this. We detect a person and we have tracked because continuous movement is there. He's moving around the same location. And here, in contrast to the intrusion, where we have used only one camera, here for tracking we have used multiple cameras. That is what the difference, and algorithms will be different accordingly. I had shown earlier the system model of the IDS, intrusion detection system, and I had told at that time that it will be somewhat similar with a little bit of difference in components. Here you can mark multiple cameras are there. There also it was there, but we have not used that. Here surveillance zone has been marked, and here we use high-end computing device because multiple cameras has to be handled. Other portions are almost same. So what are the components then? 3 steps. As I told, high-end computing, cloud computing, and user interfacing. So same as it was edge computing, now it is high-end computing. I have told the reason for which it is being done. So same camera we have used, but high-end computing device. Tower workstation, and same after this, it is sent to the cloud, and same cloud communication pattern Twilio we have used for information to the user. So here the flexibility of the user is that earlier I have told offline as well as online mode. Like intrusion detection, here the user can also have the freedom to define the surveillance zone, in which zone the loitering has to be detected. And time threshold. What we shall define loitering has occurred if it exceeds this time. The person concerned has stayed in this place more than this time. Time also, displacement also. How much should be the displacement? We should define the loitering, this person. So many people will move through the region of interest, but all we cannot tell that all are loitering. So we have defined time threshold as well as displacement threshold. How we have got all these things? Like earlier case, we have got sequence diagram, all the steps, intermediate minute details of our algorithm, and the flowchart for simplification, just for simplification of explanation. But the flowchart is a subset of sequence diagram. Minute details are in the sequence diagram. And we have told while discussing about the intrusion detection also, we want the processing time, algorithm processing time should be less. Here the steps should be taken care of. And here we have added novelty where we have tried. So first of all, the object is tracked, and next, is it loitering? That means, is there any to and fro motion if someone has stayed for a longer duration or displacement? That is what we are taking. Then here also, like the intrusion detection, we have extracted the feature. For why? Re-identification. We have used multiple cameras. The person which is in camera 1 should be re-identified in camera 2, should be re-identified in camera 3. So then it has to be tracked. Cameras need to be switched, one camera to the other camera. I shall explain this in little bit detail. What is the switching, how it occurs, how we shift one camera to other camera. It is not random. Then finally, we detect intrusion. What are the steps? As usual, object detection and tracking, loitering detection. So we confirm that the person is moving at a particular location and he might have some different intention. Then if we have detected a loiterer, then we will have the feature extraction. Then after extracting the feature, we move from one camera to the other camera to track the loiterer. Where is he going? And that is what re-identification. Same person has to be identified. We cannot identify different person in different cameras. Just tell that we have tracked it. What we have used here. So little bit upper version. LO version number 3. LO we have used, but version number 3. Accurate and fast. So it is then in comparison to short last time, that means intrusion time, we have used deep sort. What for we have changed this algorithm for tracking? We have observed that SORT is not efficient for occlusions. That much efficient. So we replace it by dipso. And frame to frame comparison has to be made, and it has taken motion as well as appearance. So all the things have been taken care of by dipso. Then how the time threshold is decided? I have told that we have taken care of time threshold as well as displacement threshold. How we define that? So here, see the expression number 3, equation number 3, delta t. TIN is the first time instant when the object is detected. Let us take camera 1. So it is the first time T in, that means he enters into the surveillance zone. N is the number of frames which the object stays. So the difference between these two is the time duration. Now, delta t for single. Then total time duration. It is then multiplied by frames per second. Total t input, total time is delta t multiplied by FPS, frames per second. And naturally, when we can detect the loitering when T is greater than TH. So that is, we can decide that. Then distance threshold. How we shall get the distance threshold? There is two things, a resultant displacement and actual displacement. So it is the difference between the distance covered and actual displacement. He may move around. Already he is covering distances, but the resultant displacement is less. He is not moving away from the same location, though he is in constant move. So when it is greater than the displacement threshold, we conclude that yes, loitering has not only time threshold, but also this one also. Both the things has to be satisfied. Generally, we can take 1/5 of the normal distance covered. We can change this one also, depending upon a requirement, what we are interested for, how much time a person should be here in this zone, so that we can declare it as a loiterer. So when both are satisfied, then we take that yes, this person has some different intentions. Then, like the intrusion, here feature need to be extracted with little bit different steps. So first of all, we can take 10 images and sorted in descending order. Classification confidence level. That means whether it is 80%, 70%, how much it supposed to get. And the highest confidence level is taken into account. That is, we choose that. And there is the app, mobile net, which is supposed to get the feature extraction. We shall use this feature for re-identification. Why we used mobile net? I have told earlier that depending upon our requirement, our available resources, we have chosen. So it has low delay. Delay is less and accuracy is high. And moreover, we are targeting a real-time application. Offline may be doing, but final target is real-time application. The person has to be detected. Immediately it has to be conveyed. Both these cases, intrusion as well as loitering, and preventive action will be taken so that much damage is not done by the criminals. Then here there will be multiple cameras. We have used here multiple cameras. So typical arrangement, it has been shown in this manner. Generally, there are one master camera and few secondary cameras. But this is adaptive also. So let me explain clearly how this camera switching occurs and how the master camera becomes secondary and secondary camera becomes master. Secondary master camera is, let us designate as CM, and secondary as CS, subscript S. So it will be a union of both set of cameras. Generally, standard procedure, here also what we have taken, one master camera and 4 secondary cameras. That solves the purpose. Our case, maybe for other persons, other users, they can use more. There is no objection. Algorithm will remain same. So each camera has got a camera switching boundary. That means the object has to be detected when it is within this zone of camera 1, let us say. So we take anyone, whenever a person enters to any camera switching boundary, it becomes a master camera. That means the person is first of all detected in this camera. We have used this, but as I told, it can be reconfigured. And when the person concerned, he is in constant move. He moves from view of the one camera to the other camera. Then it is switched, and that is called camera switching. And it goes to the corresponding camera in which direction the lateral this person has moved. Now this secondary camera which was there, now it becomes master camera. So the designation is adaptive, dynamic, and it depends upon the location of the lateral. So instead of processing all the camera feeds, we generally look at the master camera feeds, and that will reduce the computational complexity. So the feature has been extracted. Both has been compared, camera 1 feed and new master camera. That means the lateral has, this person concerned has in the zone of camera 2. So it is compared, similarity, triplet loss. So one after second feed is compared. So we have taken triplet loss because classification loss use more parameters. Triplet loss in these cases for cross image representation, it works well for us. Then almost similar in the manner, we have got experimental setup. Here we have got high-end computing system. As I told, few things are different, few things are similar. So in fact, I have chosen these two, intrusion and loitering, due to its bit similarity, bit difference. But both comes under crime detection. Then like the intrusion detection, here we have loitering detection. Offline mode for later processing, online mode for live processing. Then we have done experimental verification. Here you can see the bounding box in the sketch A. Here we have not detected because it does not match, the person concerned in A does not match the time and displacement threshold. Then sketch B, the same person is moving around, and the person which is detected, see the blue marks, it is the movement, the person is moving. In sketch B, see the blue mark on the ground, the person is moving around, he is not going away. This is the path which we have shown. So we have also detected a loitering profile. When it threshold overcomes, we decided that yes, this person is loitering, and we have plotted in the figure C its loitering profile. This is all offline processes. What I have discussed is offline process. Then there is online processing. We attempted the online processing also. As I told, this is around our electronics and communication building. The sketch A, the surveillance zone, we have initially detected a person has entered, but we cannot tell that he is a loiterer till it satisfies the time and displacement threshold. It stays there for a long time and does not have sufficient displacement, resultant displacement. But same thing is not in sketch B. See the blue line is on the ground. It has become red also. That person has become red also. That bounding box has become red. That shows, the blue line shows the movement of the person on the ground. I shall show a video in this regard, particularly this one, after this talk. Then that is camera 1. The person has moved a little bit. So in the camera 1, after it satisfies time and displacement threshold, we have designated him as a loiterer. As I told, all we cannot make it like that. It has to be satisfied. So once it has been tracked, once it has been detected, it has to be tracked, de-identified. And same we have done in camera 2. And again in camera 3, even if it moves away, we have got its features. We are not locating anyone else, targeting anyone else as a loiterer. Exactly, we are following that. So that is the detection here. Like the earlier cases, we have also get a evaluation loitering profile, how much time it has remained in the surveillance zone. Then we have got a real-time notification here in WhatsApp messages. First line is camera 1. Loitering is detected at camera 1. Time is also mentioned, 5:18 p.m. Then again in camera 2, time is 5:23 p.m. That is not going. And again in camera 3. So that means the duration also we are taking note of. Then like the previous case, we have got a comparison. Different algorithms, different re-identification techniques. But still, we have got best results as far as the accuracy is concerned. This is our proposed LDS. In right-hand side, the accuracy 96% without re-identification, but 81.5% with re-identification. Why it is happening like this? With re-identification, because same loiterer which is there in camera 1, because in the previous cases, we are not tracking. 96% is a single camera. So in the single camera, we get the results. I think someone's microphone is on. I'm getting noise. So without re-identification, definitely we shall get more. But when you go for identification, we are dealing with multiple cameras. So there may be a possibility someone we have missed. Possibility is there. So that is the reason why we are less. But see the other algorithms. They have not used re-identification. So if we compare without re-identification of all three, ours is the highest, 96%. But still, another advantage, we have used re-identification. Re-identification is the 100% confirmation that this person is the criminal. And all other algorithms, they have not used re-identification technique. This is a contribution for us. So let me summarize what I have told till now. We have used multi-camera surveillance network. We have used re-identification in different cameras. So it is more efficient when you add re-identification to the detection algorithm. So generally, that is the two methods which I was supposed to tell, because as I told, there are different domains. Even in security, there are also classifications. But due to time constraint, we have done others also, anomalous detection, so many things we have done. But I have chosen both these two, taking into account the time constraint. It is also here a optimization technique. So we have discussed initially about what exactly the smart city should be. Then little bit of preliminary introduction, what is required in our case. In fact, AI is extensive, IoT is extensive, but we have concepted little bit, make it to the point as far as our requirement is concerned. We have developed two video-based criminal activity detection. So intrusion as well as loitering. So finally, acknowledgement for the project, that is Imprint, MHRD, and Ministry of Housing and Urban Affairs. It's a multi-crore project. Few faculty members are involved in this. I am taking this domain. Someone else is taking traffic management or accident detection. Then finally, I was telling there is a long list of references. So I'm just scanning through all these things. If you're interested, they can follow from these slides. That is what I was supposed to tell for this discussion. But before I conclude my talk, I have to show two videos, as I had told beforehand. Intrusion as well as loitering. So it will take a little bit of time for the videos to on. So first of all, because I have discussed intrusion, so I am showing the video on intrusion. So the car is moving. We have a little bit make it slow so that our algorithm can be best visualized. Region of interest we have shown. Mark this green line. So as soon as the car enters, there is a beep signal to the person that the region of interest has been breached. So classification has to be made as this is the car which has crossed. But here also, if it is simultaneously, we can tell that multiple classes detect, that is also possible. Human beings as well as car, different classifications can be made, and we have to select. The user can tell who are supposed to be included. If it is a, let us say, cow or any living being other than human being, it will not be treated. Classification training, it is user should do that. So that is what the practical implementation, this video of which you have seen. Let me show the next one. The loitering detection. So hope you remember what I told till date. So the person is starting to move, but till date it has not been declared as a loiterer. So then, because he has crossed the time threshold and displacement threshold, it is identified that this person is a have criminal intention because he is moving around. So we designate him as a loiterer. That was feed of camera 1. Now the person has moved, and now it is in the domain of camera 2. We have taken all practical scenario. We have not told anyone that we are doing the experiment, you do not come, or there is some issue in this case. We have not told. It is free because that is natural, online, and the person moves. But see the speed. It will take some time because till it goes over to. So this is camera 2. So the camera switching I was discussing. So now the camera 2 is the master camera. Others become secondary. All the information has been transferred to camera 2. And the movement is being shown in blue line. And the bounding box, it is in different color to make a mismatch, to make a difference. Same bounding box is there in one more person in the left also. But he is not considered as a loiterer. Only blue lines follows the person which we have designated that yes, he has been declared a loiterer. One more lady comes over, crosses our intended loiterer. He obstructs. Occlusion also occurs. I have mentioned about the occlusion earlier. But still, the camera locates that yes, this lady is not a loiterer, even if it crosses, even if it obstructs it, occlusion occurs for the loiterer, still it tracks it. And now camera 3 is the master camera. So that is what the total, what I need to tell. And now it is open to questions.
Yeah, any queries from any of the participants?
So I think I have maintained the time. It is almost approaching 5.
Perfectly.
So,
Is this a NIT campus?
yeah, actually, it has suffered a lot of changes rather than improvement. And this is the new building.
Yeah. I could recognize the campus.
Yeah,
So any
right.
queries from anybody?
And generally, I choose a topic for this type of talk, which is of public interest, not going into too much of mathematical details or making it boring. So practical implementation, practical aspect, that is my target. So for this reason only, I choose this one, which though they do not have any
I can
much
see
knowledge.
thank you messages in the chat box, but I think they are all satisfied. Yeah, I can see thank you messages in the chat box.
Yeah, right. When there is no question.
Hello. No, sir,
Either,
one more question. Hello. Am I
Yeah,
audible?
yeah, Tejaswini. Yes,
yeah,
you are
right.
audible.
Audible. Audible, audible.
Actually, I am new to this IoT. I don't have much idea. I just wanted to know, is there any other means research area which can be where image processing or video processing can be merged with IoT?
Yes, actually, I mentioned on that day. It's a evolving field, and it is the new catchment area as far as the research is concerned. Whatever the concept I used on IoT can be applied, except the initial portions. If you can remember the model, system model, camera 1, camera 2, edge computing. After edge computing, it becomes IoT. So till we give it to the cloud will do the rest. And it has got a lot of application. Our complete domains of smart city is in this domain itself. And
Yes, like you have identified like that is accident detection or traffic detection.
yeah, right. Because it's a voluminous data. Because particularly smart city, when you take accident or pollution, anything you take, this is a voluminous data. And those are all transferred to the cloud. So it has got a lot of applications. And as far as this side is concerned, it is evolving. It is making our job easier. So much of data, all the things, handling becomes easier.
Okay. One more thing is that like whenever we are interfacing it to the cloud or providing to the cloud any hardware or software requirement, because in the requirement I think you have not
Now, I
mentioned
have
only
mentioned everything.
GPU.
Actually, whatever, just interrupted, whatever it is required, I have given. If something is missed, it is not there. So I have, let us say, edge computing or high-end computing, all the components which is used, the keywords which I have mentioned, if you later on search for it, then you will get this. Almost all the components I have mentioned. I have not missed anything. Everything I have mentioned.
Okay.
No. Thing is, how did you manage to do this setting using the cloud support? Which is the platform? How did you do
Actually,
that?
I may be very asking some basic question like whenever you are transferring the message to WhatsApp or emailing, what is the actually requirement? How it could be done? Or if I'll be starting in this domain, what is your suggestion? Where should I start?
Transferring the messages to the WhatsApp email has become very much
Is
rudimentary
it
because
Amazon Cloud or some other subscription you have?
in fact we have our own cloud here in our United Arab
Okay. In
Cloud.
the campus, you tested it. Okay.
Yeah, right. Because
Okay.
actually sometimes we may not depend. It's a voluminous work, and so many. As I told, we are dealing with. I am speaking on one domain, and to two activities of criminal only. So it is better to have our own resources.
Okay. Okay, sir. Thank you.
Sir, good evening. You have mentioned, sir, your hardware and software requirements. So my question is, this method can be implemented on some other system also with low specification, or these requirements are mandatory to implement this method?
Yeah, right. Actually, we have set some targets, some parameters to be satisfied, the requirements. So that these components, what I told, which I've used, best suit for that work.
Okay, sir.
Let us take an example. What I have discussed, intrusion. That is one aspect. We are thinking that this much is the complexity, this much is the movement. So in that context, we decided that these algorithms will work. In fact, what the question you are asking, it can be generalized. But if it is customized, it gives best result. That means same thing what we have used here can be used in other applications as well. But we are interested for a best result. We are handling a imprint high value project. So still we are developing upon that. Actually, this is a continuing process. So high value project. So that we shall have a good accuracy, good optimization, because we are answerable to MHRD and Ministry of Human, because they will implement it. So many smart is coming on, and they are supposed to use our algorithm. So that optimization we have made. But still, if you are using for a private mode, then you can use this one and check how much accuracy you are getting, and then play with the algorithms also.
Okay, thank you so much, sir.
Yeah.
Sir, one more question. Is there any specific reason of selecting darknet deep learning network? You have used in darknet in your one slide. It is written.
Actually, in this sense, no. Actually, it is not. It is not. I have made this yellow V2. Why I have used yellow V3? Why I have used then short, deep short. So those are the justifications I can give as far as the deep learning is concerned. So there are other choices also, but there is the for our specific for our requirement, because that is also used in different applications also. So, but for our application, I have taken that one, deep learning, and that segment of deep learning.
Okay, sir. Thank you.
And deep learning, I have told at that time also, the data handling, because particularly all may not need this. Machine learning will also be enough for them, but the volume of data the smart city generates, still we are less. One camera, two camera, three camera, like that only. And when it is practical setup, when we install in a city, maybe more number of cameras will come in picture. So keeping in mind, and in fact day by day we are evolving also. So it is in constant process. Both these works has been published, presented in IEEE conferences. Again, we are going for higher end. So these are all recent works.
Any more queries?
Excuse me, sir.
Yes.
Sir, does this intruder tracking have been used in India, or it is first of its own kind?
No, no, no. Actually, I showed few algorithms also. That comparison table for intrusion, not only for intrusion, for loitering also. I showed few algorithms. The reference numbers are there. You can check it. Because I have given the references, algorithm name I have not, person concerned name I have not written. So people are working, because no domain is restricted to India nowadays. So it is all over the world. And smart cities is not in your, we are lagging behind other than, but others are more smart than us. We are trying to match with them. So this universal, many people are working on this. And literature survey will give a clear picture that so many people are working on this. It's a top competition.
Okay. Thank you, sir.
Okay.
Okay, Dr. Pati, it was a fantastic talk. Concept is very new. As we know nowadays, when we talk about any smart environment, privacy, security, these are the key concerns. And definitely to make our cities, as Government of India has promised, smart cities, these kind of technologies will be really useful and also required. So thank you for sharing your research activities, your findings. See you in future again.
And before I say, before I sign off, I should thank you, Professor Patnaik, for giving
It's my
me
pleasure.
the
It's my pleasure.
platform to speak. And thank you, participants, because as I told, this is post-launch session. To keep the energy level high at this session and to get involved. I do not know, because many of you might have overhead transmission also if I have missed it, but I have tried to keep it under, not overhead transmission, into the region. But thank you very much for a patient hearing. And it was nice to meet you now, and hopefully we shall meet in future in different domains also. My details are there in the website. My details are there in the website. If anyone interested to contact me or interested to clarify any queries, he is free to contact me. So thank you very much to all.
Thank you, sir. Thank you, sir.
So it is the time to sign off, I think.
Yes. You can sign out.
Thank you very much.
Okay, the participants. So this is the end of day 3. So see you all tomorrow morning again with a different kind of session, which is also very much essential considering the way this COVID is happening around us. And tomorrow the morning session, this will be on yoga. Okay. So in kit, kit various campus, this kind of activities are going on and people are getting lot many benefits out of it. So tomorrow the speaker, Dr. BB Kar, she will be addressing about this. So see you all tomorrow morning.
Okay, thank you, ma'am.
Okay.
Thank you,
Thank
ma'am.
you.
Okay.
Thank you, madam.
Thank you.